asynchronous programming, which is a different style of programming than what I guess a lot of other programming languages are. And it's important for JavaScript because it's a web language. So now let's start with an example. Let's say you want to send an HTTP request. So what an HTTP request is, it's basically like you're sending a request. So just think of it as a request for some data to a server. So when you go to a website that is an HTTP request, it's actually a GET request because you're requesting to get some data from the server. So just think of it like a request. But when you send a request, right, you don't instantly get a response because it has to go through the internet. It has to go to their server. Their server has to do the processing and then send you back the data, which will go over the internet again. So there's going to be some latency between your request and when you get your answer, your response. So the question is, what does your program do when it's waiting for the request? When it's waiting for the response to the request? Now your program can't just freeze and do nothing because let's say you have an app, right? If you wanted to click a button, have a user click a button to fetch some data, your app can't just freeze and everything just stop working while the request is pending. So the solution for this is we have asynchronous tasks in JavaScript. So you can see this nice little diagram here. What synchronous tasks are is only one task can happen at a time. So like you see these three tasks. In synchronous, we just line them up. So first is fetching data from API. That's like sending a request. And at the very start, it would just send the request and then freeze basically, and then wait for the data. And then it would do the next tasks and so on. But that would be a pretty bad user experience. So the solution is we have what's called an asynchronous model. What that means is at the very beginning, we send all three requests, or we do all three tasks, we start them, and then we wait until the responses come back. Then we do something with the responses. But in the middle, the app is free to do like whatever it needs to do. So it's not, essentially the asynchronous requests don't block the thread. They don't block the execution of the app. So that's why at first we start and then we wait until they come back and then we do something with the response. Otherwise, we just let the app run. So an example is an event listener. I'm sure you guys are all familiar with event listeners. So let's say we have an element, right? We get the document.getElement by ID. That gets one element from the HTML. And then we use the addEventListener function. So we listen for a click event, and then our handler is this function. We can console.log my element was clicked. So this is an example of asynchronous programming because your app doesn't just freeze when it's waiting for the user to click a button, because that would be kind of bad because your website would just stop functioning. So what it does is it says, okay, when a click happens, then run this function. And that's basically how all asynchronous programming works. You don't have to say like in Python, we have the time.sleep function. That basically blocks the entire thread from executing for a certain number of seconds. But in JavaScript, we don't have that. We wouldn't block the app from running if it was waiting for the user to click a button. Instead, we would just have this handler function that makes it asynchronous. Okay, so.
Yeah, actually, Jerry, just 1 second. Welcome, Xiao Chao. Thanks for joining us. So Jerry is going over asynchronous programming. So you can just follow along now. And then if you want to view the beginning of this lesson, you can watch it on YouTube once we post it.
So the first step is we need to understand how asynchronous programming works, because it can be a bit hard to get used to, especially if you haven't worked with asynchronous tasks much with other programming languages in the past. So set timeout is another example of an asynchronous function. This is well, I know you guys have all used set timeout for waiting, right? So set timeout, it just calls a specific function after a certain number of seconds. But it's not like time.sleep. It doesn't block the thread. It's asynchronous because the function is called after this in this case, 1000 milliseconds has passed. But in those 1000 milliseconds, the app is still free to do stuff. So actually, let me run this code example just to demonstrate what I mean. So yeah, another cool trick is you can run JavaScript in your console whenever. So this code, what it does is first it'll console.log hi, and then after 1 second, ignore the warnings. After 1 second, then it will say execute, because this set timeout does not block the hi from running. That's the point. It'll only execute after 1 second, and in the meantime, the app can do whatever, like console.log hi. So this lets you wait in an asynchronous manner. What is this slide? I guess, okay. This slide is just trying to demonstrate that even if your function is in the middle, it'll still execute hi and bye before executing the callback after 5 seconds here, right? I guess that's pretty much like the last slide. So this code will be in this diagram. So what happens is, actually let's wait till the GIF resets. So here, just take a look at this code. First we console.log hi, right? Then we set a timeout for some function to execute, cb1, after 5 seconds. And this function will console.log cb1. And then the last thing will log by, essentially the end of the program. So, okay. So what this GIF shows is it shows how JavaScript will process the events that's happening in this program. So at step 1, your browser console will display hi. So console.log hi is in the call stack. And then it'll process the set timeout right here. And then it'll put the cb1 into a timer. So basically it's executing separately. Then it'll console.log by, because that's after. And then after 5 seconds, it'll push this function cb1 into the call stack, and it will log to the console. So that's why it doesn't block the thread. It's because it sets the function to execute after timeout has been fulfilled, but it does not execute the function directly or just pause the entire execution for that amount of time. So I'll let this GIF play one more time and you could just see how it works. Okay, so it does not block a thread because the timer is set in a separate part. So what this allows us to do is optimize the event loop. What that means is we don't block the thread every time we need to wait for something. So the JavaScript scheduler will order the tasks, like in the GIF. It'll order which ones need to come first, and it'll wait on other functions, but it won't pause the thread. It'll add callbacks to the stack, so that's just how you saw it processes. And then, but one important thing to note is that JavaScript is still single-threaded. What that means is there's only one thread running operations at a time. Some other languages have multi-threads, which means like 2 threads can continuously run operations. But JavaScript is single-threaded. It only has a smart scheduler that will schedule tasks to be executed later. But there's only one thread running at a time. That's important to understand. So now we're going to introduce an important structure for asynchronous programming, which is the promise. Now, promise is something that you can use to say that it's just like a promise. We'll fulfill or reject the promise in the future. We don't know how long in the future. So a promise lets you basically wait on something without blocking the thread. So we have this function e right here, and we have this new structure. It's a constructor. So we say return, and then we return this promise that we're creating right now. So it's a new promise, right? And then the promise will take a function that will take 2 arguments, which is resolve and reject. Now these 2 arguments are functions in themselves. you could call the resolve function to resolve the promise, or the reject function to reject the promise. So in this case, we're only using the resolve function. We are going to resolve the promise after 5 seconds, after the set timeout. So how we would use this is then we first call E, and then promises have this special property called .then. And what .then does is it takes a function that will be executed after the promise is fulfilled, whenever that may be. So after it's fulfilled, it'd say my promise is resolved, the result, right? And then .catch is another special function, and .catch will happen after the promise is rejected, if it was rejected at all. So if there's an error, we'll console.log there is an error. So I'll run this code example. So first E is called, right? It says promise pending. Then after 5 seconds, we should see my promise is resolved. So there it is. We resolved the promise after 5 seconds, and then this code in here will be executed. But we're not blocking any other operations while we're waiting for the promise to resolve. So I can just say like for, say we print all the numbers from 0 to 9. We could still print all these numbers while we're waiting for the promise to resolve. So that's basically what promises let you do. I'll also show an example of what happens if it's rejected. So let's say we had an error in our code and we wanted to reject. So say reject error. If it was rejected, then that .then would not be called. It would go straight to the .catch. So after 5 seconds, it'll say we had an error, and the error was what's in this argument right here. We rejected error. So that was our result. So that's how promises work. They're, I guess, pretty straightforward. But yeah, this is a good example. Do we have time to show this example?
Yeah.
Or should I skip? Oh, we do have time. Okay.
I think so. We have about 6 minutes.
Okay, I guess show this example, which I made for the summer camp a long, long time ago. Hopefully it's still up. Is it still up? It's just waking up, yeah. Oh, no. Oh, this is a Node.js REPL. Oh, okay. It wasn't a website. Okay, well. So our code here, this is just an example of fetching data from a API. So basically sending a request and then waiting for a response. And this uses promises. So we have Axios. You don't have to worry too much about what that is. This is just a library that will let us send requests. So we have Axios, then our API URL. This is the URL we're fetching the data from. Actually, we can go to this URL right now. So what it does is just gets this. So it'll get like this text right here. And so what we do is we have a .then. This will happen after the promise is resolved. So after we fetch the data, this .then will be called. And then in .catches, if there's an error, let's say the website is down or something, then the .catch will be called. So we could run this. So it'll say we fetched the fees, and then here they are. So that's the result, and this was in the .then. That's just a quick example, I guess, of how you might use promises in real life or in your code. Okay, async await is another way of using promises. So if you don't like the .then or .catch, you can use await to basically replace the .then. So what happens is we have an async function here. It's called getFees. It does the same thing as the last example, right? Except now we're using async await. So what await does is it, as the name suggests, waits for the request to finish, and then we'll assign it to this variable fees. And we could console.log them. But you have to note that await does not block the thread because it is inside of this function that is labeled as async. What it will do is it'll pause the execution of this function, getFees, and then after the data is fetched, it'll continue. But since the function is async in itself, it will not block the rest of the program from executing, only the code in this function, which is fine because you're waiting for the data to be fetched anyway. So what this does is this avoids really, really long chains of .then. So inside of a .then, if you want to call something else that's async, you don't have to put another .then, and that can really quickly build up. So async await fixes that by allowing you to just await some result and then assigning it to a variable and then using that variable. But you have to use await inside of a function that's called async. Otherwise, JavaScript will yell at you. So you can use async await if you want, or you could use .then and .catch. Both are valid. I myself prefer async await, but that's just your personal preference. Okay, so yeah, the code is still asynchronous, and you could see this little diagram right here that will just show you how the async await works. So we have the main, the arrows are the execution. So here's our main code, I guess. And then we go inside of the async function, and then when we await, we're awaiting these two promises, and then we'll go back into the main execution. So I guess that's async await. It's just another syntax for using promises, basically. I don't think we should, okay, I guess XHR is another good example of asynchronous programming, but instead of promises, since it's a pretty old API, another method of asynchronous programming you could see is callbacks. So promises have the .then and .catch notation, but what callbacks are is it's like add event listener. Instead, you just pass in a function that you want to be called when the request is fulfilled. So I don't recommend using XHR, but this is just an example of callbacks. So instead of using the Axios, which is more modern with the .then and .catch, here we have XHR. So we're just making a new request, we're opening it, and we're sending it. You don't really have to understand what that does, other than it just sends a request. And then our callback is rec.onload. So that's a property that will be called once the request finishes. And then what we do is we assign this to this function. And what this function does is just it console.logs the response of the request. So instead of using a promise with, okay, this thing is annoying. Instead of using a promise with .then and .catch, we just use the onload callback, which is also something you should get used to using callbacks because a lot of older APIs will use them. Okay, error failed. Okay, well, I guess the website isn't working currently, but that's fine. I guess it's just using a callback. So requesting data from APIs is an important application of asynchronous programming because it lets you fetch real-time information, and also, like, well, your website, of course, will have real-time information. Otherwise, it would be a pretty useless website. So I guess here's the website version of the example that fetches the fees. And this will just use a request to fetch the fees from the API, and then it'll display it on this website. So right now it's actually pretty expensive. So we could see in the background here, I'm using this animation that will cause the little Bitcoins to fall down on the page. But when I refresh, when I'm fetching the data, the animation doesn't freeze because it is running it asynchronously. So that is why asynchronous programming is useful, because you could send all of these requests and then it will not freeze your website. So this is, in the end, an application of what you could do with asynchronous programming.
Nice. Okay,
Okay.
let's pause there for today. Very good job, Jay.